Good morning, everyone. And my name is Prakash, and today I would like to discuss about thin spherical shells. So, this figure shows a thin spherical shell of internal diameter d and thickness is t, and this sphere is subjected to an internal fluid pressure of pressure P. So, initially, the fluid inside the shell has the tendency to split this sphere into two hemispheres, that is along x-axis. That means this is one hemisphere and this is one is the second part. So here the force which has tendency to split the shell is, here the force I am considering as P, that means pressure. The force which has a tendency to split the shell is, so as we know, the formula for pressure is force by area. So here the force is pressure into area. So initially the pressure of the fluid is P, and on which area the fluid pressure is acting. So here the pressure is acting at this area. So area of the sphere is pi by 4 d square. That means which indicates the circle, pi by 4 d square. So this is the force which is used to split the shell into two hemispheres. So due to this force, the material of the sphere will develop a resisting force. So the area resisting this force is, the area resisting this force is pi dt. Pi dt. That means here pi d is nothing but circumference on which area the resistance force is developed, that is the thickness area of the sphere, that means pi d into t. So therefore hoop stress, due to this resistance force, hoop stress is induced in the material of the shell. So the hoop stress is given by, here I am considering hoop stress as sigma 1, is given by resisting force by area, that is resisting this force, resisting this force. So here the force is P into pi by 4 d square. This is the force which is equal to the resisting force, and the area is pi d into t. Here the pi cancel and d cancel one time. So here the answer is Pd by 40. So this is the hoop stress for the, so this is the hoop stress for the thin spherical shell. So we also consider the and also this sphere has also tendency to split in y axis also. So here the splitting takes place in x axis, and also it will be able to split at y axis also. So in y axis also the formula is same because the sphere is symmetrical. So that's why here the sigma 2 is also Pd by 40. So the only difference between sigma 1 and sigma 2 is, here the stress sigma 2 will be at right angles to the sigma 1. So let us look at a problem related to thin spherical shells. So here given a vessel which is in the shape of spherical shell, so which has an internal diameter 1.20 meters and thickness is 12 mm and which is subjected to an internal pressure P is equal to 1.6 Newton per mm square. So here we have to find the what is the stress induced in the material of the vessel which is in the spherical shape. So initially we have to write the given data. So what is given data? Given internal dia is, that is small d, is equal to 1.2 meters. So convert into mm, that is 1.2 into 10 power 3 mm. After that, given shell thickness. So here we are indicating thickness as t, that is equal to 12 mm. So and also given fluid pressure, that is P is equal to 1.6 Newton per mm square. So what is the formula for stress induced in the material of this spherical shell is sigma 1 is equal to PD by 40. So here the P is 1.6 and D is 1.2 into 10 power 3 divided by 4 into 12. So here we can consider 16 into 12 into 10 divided by 4 into 12. Here 12 cancel, 4 4 is 16, that is 4 tens are 40 Newton per mm square. So this is the stress induced in this spherical shell. Okay, thank you.